This video is essentially a review of what you should have learned in grade 10 about quadratic relations. We're going to go over the properties of the graphs of quadratics, and we're also going to look at different ways on how to solve quadratic equations. Quadratic functions can be expressed in different algebraic forms. First, we have standard form, and this form is just a quadratic that is fully expanded and simplified. Factored form is also very useful because in factored form, this is just the quadratic relation where it's fully factored, but it also allows us to easily find our x-intercepts or roots. And lastly, we have vertex form. So vertex form is actually really helpful because it allows us to clearly identify what the vertex is right away just by looking at the equation. But it's also helpful when we're graphing because we can easily see what transformations are happening to our quadratic functions when it's in vertex form. On the right, we have a graph of a quadratic function, and whenever you graph a quadratic function, it always forms this shape. It's called a parabola. Parabolas have particular properties. So the first property I'll go over is the vertex, this point right here in green. So the vertex is either going to be the lowest point or the highest point in the parabola shape, and it's also the point at which your parabola starts to change directions. All parabolas are symmetrical, so they do have an axis of symmetry, and that's just going to be the line that splits that parabola directly in half. It also actually goes through the x value of your vertex. And then we have our intercepts. So our y-intercept is when our parabola crosses through the y-axis, and it's always your y value when x is equal to 0. And then we have our x-intercepts. So these are also known as the solutions, and they're known as the roots, and they're also known as the zeros. And these are the x values when your parabola crosses through the x-axis. These will always be the x values when y is equal to 0. Let's identify some of these properties on these graphs. So we're looking for the axis of symmetry on our first graph, and you can do that by just looking at the graph. It's always just going to be the line that splits that parabola directly in half. And by looking at this graph, a line or the axis of symmetry is x equals 1. So that's the equation of that line. And another way to actually find the axis of symmetry that might be a little bit more accurate if in your graph it's not so clear, you can pick 2 points on opposite sides of the parabola. So this is often going to be the roots, but you could pick other points. And in this case, our roots or our x-intercepts are -2 and 4. So your axis of symmetry or line of symmetry is always going to be the average between those two numbers. And we find that number by adding them together, so -2 plus 4, and then dividing it by 2. And when we do that, we're going to get 1. So x equals 1 is our axis of symmetry. Next, we're going to look at our vertex. So the vertex is that highest or lowest point in the parabola, and that's going to be right here. So we're looking for the coordinates of that point. And it looks like the coordinates of that point are 1, 9. And then our maximum or our minimum value, so this is actually the highest or the lowest possible y value in our parabola, in our graph. And it's always going to be your y value of the vertex. Our highest y value, that maximum value, is 9. So that definitely should have been a review for you. I do want you to pause this video and try this next question on your own and identify these properties. So here are those properties. Our axis of symmetry, the equation of the axis of symmetry is x equals -5. Our vertex point is -5, -4, and our minimum value in this graph is -4. The next question asks us to find the vertex and then sketch the parabola. And this is our quadratic equation, which is in factored form. So factored form easily gives us our roots, our x-intercepts to our parabola. So you might be able to just look at this equation and spot the roots right away, but you can also solve for it. So we know that all x-intercepts have a y value of 0. So we can substitute that y value into the equation and then solve this equation for all of those possible x values. So we're looking for the x values that would make this equation equal to 0. So these three things here, they're being multiplied. So what you can do if you don't know how to do it right away, you can just separate these. So what x value would make x minus 4 equal to 0? And that's just when x is equal to 4. And then what value would x minus 2 equal 0? And that's just when x is equal to 2. So those are our 2x intercepts, which we can graph right now. Okay, and we're looking for our axis of symmetry because we want to know what that x value is. So our parabola gets split in half down the middle right here. So we can eyeball that from the graph, but if we were unsure, we could just add these two x intercepts together and then divide them by 2. So our x value would be 3. And to actually find the vertex, the y value of the vertex, we can just substitute that x value into our original equation. So every time you see an x, we're going to replace it with 3. So it's going to be 2 times 3 minus 4 and multiplied by 3 minus 2. And then we need to just solve for y. So y is equal to 2, negative 2. So that means our vertex is 3, negative 2, and that's the point of our vertex. So that would be our parabola. Let's review your skills in solving quadratic equations, and there are different ways to solve them, but depending on the algebraic form of your quadratic equations, some methods are much easier than others. For instance, if you have only one x in your equation, then the regular solving equations method would work. And what I mean by that is just by using the balancing technique and using opposite operations will work for this. If you don't have one x, you see more than one x, for instance, if it's in standard form, you want to factor that quadratic. And remember, your quadratic has to be equal to 0 before you factor it in order to solve for x. And also, if your equation is not factorable, then our last method would be using the quadratic formula, which is right here. So your quadratic has to be in standard form. It needs to be equal to 0. And your a value is just the coefficient in front of your x squared. Your b value is the coefficient in front of x. And your c value is the constant number. So you got to input that into the quadratic formula and solve. Here's our first example, and as you can see, we only have one x. So we can solve this using our regular solving equation methods of opposite operations and using BEDMAS backwards, okay? So the first thing we got to do is get rid of this minus 10 here, and we got to do the opposite, so we're going to add 10, making this 2x minus 1 squared equal to 18. Okay, and then the next thing we got to do is get rid of this 2 that's on the outside here, and we do that by dividing by 2. So when we divide by 2, we can cross this out, and we're going to be left with x minus 1 all squared equal to 9. Now we can actually get rid of that power of 2 here, that's square, so we can square root everything. So once we square root everything, we're going to be left with x minus 1 equal to the square root of 9, which gives us two possibilities, a positive 3 or a negative 3, because positive 3 times a positive 3 equals 9, but also a negative 3 multiplied by a negative 3 equals 9. So we have two options, and this is going to yield us two possible answers for x. So we're almost done. We've almost isolated x, but we got to get rid of this minus 1 by adding it. So we're going to add 1. So this is going to give us our two options. So x is going to be equal to either 3 plus 1 or x is equal to negative 3 plus 1, which means our first x, x1 is equal to 4, and our x2 is equal to negative 2. Here's our next question. So if you think you know what to do, go ahead and do it. Otherwise, you can just continue watching. Now, here's our quadratic equation. There are two x's, so we don't want to just solve in our regular solving equations methods. But let's actually try to factor this. But before we factor it, we got to move this -2 over to the other side, because when our equation is equal to 0 and then we factor, it's going to be easier to solve that equation for all your x values. And when we move that -2 to the other side, we're going to get 0 equal to x squared minus 3x plus 2. Now we're going to try to factor this. Our coefficient in front of the x squared is 1, so we can use our sum and product method. So we're looking for two numbers that multiply to give us 2, but when we add those exact same numbers, we will get -3. So factors of 2 that make this work are -1 and -2. So using those two numbers, we can rewrite this equation in factored form. So it's going to be 0 equal to x minus 1 times x minus 2. Okay, and then we gotta solve for our x's. So what values of x would make this whole thing equal to 0? Well, our first x is going to be 1, positive 1, and our second x is going to be negative or positive 2. Here's our next question, and there's a lot of things going on over here, but the easiest thing that you can approach this question right now is to get rid of these brackets and distribute those terms that are in front of those brackets. Okay, so do that right now. Once you've expanded, you'll get this equation, but we still got a lot of terms here. So let's bring all of these terms on the right to the other side of the equal sign and group our like terms. So you should get 15x squared minus x squared minus 12x plus 2x plus 4x minus 12. And we got to combine all of those terms together, and you should get 14x squared minus 6x minus 12 equals 0. So there is a common factor here. We can make this a little bit easier to deal with. So our common factor here is 2, but we can divide this whole thing by 2, both sides, because it is an equation, to just kind of reduce all of our numbers. And our equation, our new equation, is going to be 7x squared minus 3x minus 6 equals 0. Okay, so let's actually try to factor this. We have an equation in standard form, and if we want to factor this, we're looking for two numbers that multiply to give us -42, so that's a times c. But when you add those two numbers, we're going to get -3. And do we have two numbers? Do we have two factors of -42 that will add together to get -3? We do not, okay? So that means if it's not factorable, we can use something called the quadratic formula. Do you remember that quadratic formula? That is x equals -b plus or minus the square root of b squared minus 4ac, and it's all over 2a. So our a value is 7, our b is -3, and our c is -6, so we can input those numbers into our quadratic formula. And once you start solving that, we're going to get 3 plus or minus the square root of 177 all over 14. Okay, so this is going to yield us two possible answers. So our first answer, and I'm just going to keep this in exact form, I'm not going to put it in the calculator, it's going to be 3 plus the square root of 177 all over 14, and our second answer for x is 3 minus the square root of 177 all over 14. So those are our two solutions. Here we have another question. I want you to pause this video, choose an appropriate method, and find your x-intercepts. So here's my solution. I factored this. A is not equal to 0, so I had to use decomposition. So we're doing two numbers that multiply to give us a times c, which is -14, but add to give us our b value, which was -13, and those two numbers were -14 and +1. So we had to decompose that middle term into -14x plus x, and we had to find a common factor between the first two terms, and our last two terms we were factoring by grouping. So once factored, our equation is equal to y equals x minus 7 multiplied by 2x plus 1. And to solve this for x, we had to make sure that y is equal to 0 because at our x-intercept, y is always equal to 0. Okay, so solving for our two x's, x is equal to 7 or x is equal to negative 1 over 2. Now this isn't the only way to solve this. You could have used the quadratic formula and you would have gotten the same answers. So this next problem is a word problem, and it's really important to try to focus first on what is actually happening in the problem. So it says a ball is thrown upward and its height, h in meters, is given by this equation right here, where t represents the number of seconds after it is thrown. For what length of time is the ball higher than 16.2 meters? So it's looking for a time frame in which the height of the ball is higher than 16.2 meters. Okay, so let's actually try to draw a graph to see what this might look like. And my graph won't exactly be accurate, but it's nice to actually just visualize the problem. So this quadratic would kind of look like this. Our height is that vertical axis and time is the horizontal axis. And when time is 0, looking at our equation, if we inputted t equal to 0 in this equation, then our height when t is equal to 0 would be 1.5. So our y-intercept here, or in this case our h-intercept, this is 1.5. And I don't exactly know what our maximum value is, but we're just going to kind of assume where 16.2 is. So suppose 16.2 is just around here. Okay, this is the height of 16.2 meters, and we're looking for these x values because we want to know what is the time frame between these two x values where the height of the ball is actually higher than 16.2 meters. So we gotta solve this algebraically. So our equation is h is equal to 1.5 plus 19.6t minus 4.9t squared. And our height is 16.2, so we gotta put that into our equation because we're looking for the time when our height is equal to 16.2. Now to actually solve this equation, we want to move that 16.2 over to the other side of the equation because we need this equal to 0. Because when your quadratic is equal to 0, it's much easier to solve. So if we bring that over to the other side, it's going to be 0 equal to 1.5 minus 16.2 plus 19.6t minus 4.9t squared. And let's combine that 1.5 and subtract 16.2, and we're going to get negative 14.7. And you know what? Let's actually rearrange this so that it's in standard form. So in standard form, you would get negative 4.9t squared plus 19.6t minus 14.7. So this doesn't look like an equation that would be easy to factor, but we don't always have to factor. We have a special formula called the quadratic formula that will help us find our values of t. And actually on this diagram I should have written t instead of x because these represent time. So we're looking for our t values. And we can use our quadratic formula. A is just negative 4.9, B is 19.6, and C is negative 14.7. And our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. And if we input our a, b, and c values into our quadratic formulas, we're going to get this. So once you do some calculations, we're going to get x is equal to negative 19.6 plus or minus the square root of 96.04 And it's all going to be divided by negative 9.8. And we're going to get two possible answers. So our first x value is either going to be equal to negative 19.6 plus the square root of 96.04 over negative 9.8. And I want you to put that in your calculator. And our second answer is going to be negative 19.6 minus the square root of 96.04 over negative 9.8. So put those two in your calculators. Once you've put in your calculators, you will get x is either equal to 1 or x is equal to 3. So that means on our graph, in between 1 second and 3 seconds, our height is above 16.2. So that's a total of 2 seconds the ball is over 16.2 meters. Here's some more word problems involving quadratic functions. Try these ones on your own. Think about the problems and make sure you really try to just understand what's happening in the questions. And I'll post a link in the description box that will have these solutions.